We look at a problem from 2023 JEE Advanced Exam. It's question number 1. It is regarding the continuous function or differentiable functions from set S to T where S and T are defined as follows. It is a well-designed problem. It tests on the fundamental concepts about continuous function, differentiable functions, and here we have S the union of the open intervals, notice that they're open, and T here is a set of discrete values, 4 different values. We try to see what statements are true, right? So here's the set, there are infinite many functions from S to T, right? Now here the functions, you try to map from S and T. It's going to be the open interval, which means from 0, 1, that's open. And 1 and 2 is also open. So that is, and there's a hole here as the endpoint here. That's not in the domain. And the range here is going to be take the value 0, 1, 2, 3. Now, are there infinite many? Because this is actually infinite many possibilities. You could have different values. For example, you can take any map this particular points here to arbitrary 0, 1, 2, 3, and the next point you can also map to different values. So since the infinite many possible arrangement, right, for the mapping, so many different possibilities, right, and there are infinite many combination of it, the statement here is going to be true. Now there are infinite many strictly increasing functions. This is a y value here. And you want this function to be strictly increasing. That is not possible because if you have 0 mapped to 0 here, and the next point you want to be 1, and then the next one you have to be, there are only 4 possibilities, and then you have to map this point to maybe 2, right? And then you run out of choices because either you have to go down, right? So that's not possible. So this is wrong. Okay. Now the number of continuous function from S to T is at most 120. So continuous function. Notice that in the domains here is discontinuous, right? So we have this marks the interval here, and we have one interval here, another one here, 1 to 2, and another one's from 3 to 4. Right, this is from 3 to 4. Now here, in order for the function to be continuous, we claim that for each segment here, right, since this is discrete, it means for the continuous function, there should not be any jump, right? So which means everything must be a constant, and constant has to be one of the 4 choices here. In the open interval 0, 1, we claim that the value must be a constant. If not, we're going to have a jump. For example, if you take 2 different values, let's say 0 and 3, then somewhere there's going to be a jump from 0 to 3. That's not continuous. And your function is going to be, looks like this is a hole here, right? And the next one, you could also map to arbitrary number, 1 or 2. Let's say we map to 2. You may ask, what about the jump here? Notice that this is not in the domain. So for the points in the domain, it is continuous. So which means, so for the continuous function, we know that it must be flat, right? So this could be another assignment could be assigned to 1 again, right? How many such assignments? What's total possible? Now we have make a decision for 3 intervals, 1, 2, 3 intervals, and each one have 4 choices, right, for the values. So it's going to be 4 times 4 times 4 equal 64 possible functions. So 64, of course, it is less than 120. So the statement here is also true. Now let's look at the part D. Says every continuous function from S to T is differentiable. Now you may think, there's a big jump here. This of course is not differentiable function. Notice that by definition here, the domain is open interval here. This is open interval, which means as long as in the domain, this point is differentiable everywhere that is defined. The function is defined. For like at this function here, at this position, x equal to 1 or 2 or 3, 4, those points are not in the domain, so you don't have to consider that. So when you check for discontinuity, you can exclude those points, right? Any points in the open interval 0, 1, they are differentiable because it's a flat function, right? And the derivative is 0. Okay, so the key observation of this problem is that in order for the function to be continuous, if you only have a discrete value to map to, then the function must be a constant function, in piecewise constant function to be exact. And since this is open interval, so the statement that is A, B, C, D are the correct answer here. Let's review the thought process for this problem. First of all, it is important to know y value can only be chosen from discrete values for possibilities. That's the key in solving this problem. Now, over the continuous interval 0, 1, open interval, in order for the function to be continuous, no disjoint points, no jumps, then y value can only be constant, one of the 4 values. And constant functions, of course, are differentiable over its domain, right? And the confusing part for some students could be, oh, there is points of discontinuity here, right? However, here, those points, the border points of the intervals, they are not in the domain. So over the domain, the function, some function is continuous and also differentiable. So that's the key. All right. Hope you enjoyed the video. Please like, share, and subscribe to the channel.